Okay, so it was a lot of minutes. Okay, so when we talk about, so we've talked about slope-intercept form and point-slope form, right? So these are the two forms we know about. And remember, there are three forms. Okay, we have standard form, slope-intercept, and point-slope. So these are the two that we've learned about. Okay, this one is the one we're going to talk about today. So when I look at slope-intercept form, there's some information I can get just by looking. Okay, so the first thing I can tell from looking at slope-intercept form is what is the slope. So I can tell what's the value of the slope. I don't know why I started to put slopes. But I can also get that from point slope form, right? I can get the slope from point slope form. All right? I can also, when I look at the slope, okay, I can tell whether the graph is positive or negative. Okay, and that's for both of these, for slope-intercept and point-slope form. I can tell what the slope is. I can tell if it's positive or negative. Okay, now slope-intercept form, I can get the y-intercept, so the location of the y-intercept. And point-slope form, I can get a point on the line. You know, just a point. I don't know which point it is, but I can get a point on the line. All right? Now, when I look at standard form, I can't get any of that. Okay? And there are parts of standard form that look like I should be able to get something useful out of them, but I can't. Okay? So, the first thing I notice about standard form is that C is isolated. And I don't know if we wrote this on our notes yesterday. Okay, C is isolated, okay, in standard form. So in standard form, C, which is like the constant, just the number is isolated, and in slope-intercept form, Y is isolated. And we talked yesterday about how, or day before yesterday, in point-slope form, nothing's isolated. There's just all kind of stuff everywhere, okay? But that means, since we've got something isolated in these two forms, I can convert between these forms pretty easily. And that's one of the things we're going to learn about today. First, I want to talk about standard form. Okay, so the first bullet point I want y'all to make is standard form, it shows us absolutely nothing. Absolutely nothing, okay? When I look at standard form, I can't tell what the slope is. I can't tell if the line's positive. I can't tell the y-intercept or a point. I can't tell anything by looking at a standard form. Okay? See this number here in front of the x? Yeah. Everything we've done before tells us that that's the slope. But hey, guess what? It's not the slope. Okay? So A, not the slope. Okay? B, in slope-intercept form, is the y-intercept. But hey, guess what? It's not the y-intercept. Okay, well, maybe the number that's by itself is the y-intercept. Nope, that's not the y-intercept either. There's nothing useful in this form, okay? So here is the tip I want you to take away from this, okay? If you look at your formula chart, right, we have standard form, slope-intercept, and point-slope form. If the form doesn't say slope, it doesn't tell you the slope, okay? This one says slope-intercept form, and there's the slope. This one says point slope form, there's the slope. This one doesn't say slope anything, so you can't tell the slope by looking at it, okay? If it doesn't say intercept, you can't get the intercept from it. If it doesn't say point, and these form names, they tell you what you can get out of them. Slope-intercept, it tells you. You can find the slope and the y-intercept. And that's the order they're in, too. It's the slope and then the y-intercept. Point-slope form, they start the point before the slope. Point slope. I mean, like, they tell you what you can get out of the form. Standard form's just like form. This is a form, okay? It doesn't give you anything useful. Now, that's not to say we can't get anything useful out of that form. We just got to do stuff, okay? So, to get information from standard form, you have to do something. You have to do something, okay? And there's two possible things. I'm sure there are more things we can do, but there's two things I'm going to tell you about, okay? So thing number one, we can convert it into slope-intercept. Okay, we can convert it into slope-intercept form. Okay, that's the first thing we could do. All right, the second thing we could do is we could use a method called the cover-up method to find our intercepts. Okay. Okay. So we can't tell anything about standard 4 from looking. We have to do something. So we can convert or we can use the cover-up method. I'm going to show you both of those methods in a minute. But first, we have to know the rules of standard form. There are two rules of standard form. Okay, rule number one, A, B, and C, I'll move this up a little bit, A, B, and C must be integers. Okay, what's an integer? It's a number. Okay, so there are negative numbers, but first we had whole numbers. Well, no, natural numbers, okay, integers are, so it goes natural, then whole, then integers. So natural numbers are the things I can count. With whole numbers, we add 0. So whole numbers are 0 and the numbers we can count. And then integers add their opposites. So integers are whole numbers and their opposites. And 0. Okay? So like every little step along the way we added something. So we start with the counting numbers, natural numbers, because they're things that we can do in nature, which is count. And it's also, I mean, when you think about it, it's also the way that we learn things, right? When you're a baby, you learn how to count things because you're like, you take things and stack them up. And then at some point you learn about, you do peekaboo. And you learn about things not being there anymore. You learn about 0 when something's gone. Okay? Then, so you learn about whole numbers, about counting things. Then you learn about 0. Then you learn about, then you learn about fractions and decimals. But then for the next natural step is we learn about opposites. Then we learn about parts. And that's why after integers is rational numbers. Because then we learn about fractions, decimals, and percents. Anyway, that's not the point. We're not in that class.
But after rationals, is it like numbers?
Rational numbers are, after rationals is real.
Oh.
And believe it or not, there are imaginary numbers.
That's the square root one. That's the square root one. That's an imaginary number. That's the square root one, right?
Nope. Irrational. Irrational is the square roots. Like, yeah, pi, like square root of 3, those are irrational numbers. They're non-terminating, non-repeating. Imaginary numbers are negative square roots. No, there's no such thing as a negative square root. What number times itself is negative 4? No, 2 times 2 is positive 4. Negative 2 times negative 2 is positive 4. There's no number you can multiply by itself that gives you a negative. That's the reason why it's imaginary. But that's another problem. I'm sorry, video. I'm sorry this took a turn. But anyway, also A, B, and C have to be integers, and A has to be positive. Okay, so I'm gonna have you guys copy something down. I'll pause it so you can copy it down. So I'll write it down. Y'all write it down. When I'm done, I'll pause it, and then after that, I'm gonna show you some examples. I want you to copy all this down because I want you to pay attention while I'm doing these problems because I know when y'all are trying to write down what I'm writing down, y'all don't pay attention to what I'm doing. You're just frantically trying to write. Okay, so we're going to write these steps down, and then after we write down the steps, then we're going to, I'll show you how to do it. Okay, so step 1, find the x and y intercepts. Because there's nowhere else to write it, I'm sorry. So to do that, we're going to zero out the x term. To find, no, it's x dash, and so there's a dash between x and intercept, between y and intercept. So it's y dash intercept. Just don't worry about it, just write it. Sorry, I'm going to stop talking. I'm going to zero out the y term to find z. And then step 2 is use b and z to find slope. I know it's a lot. Cover-up method is best for matching standard form to a graph. Cover-up method is not actually the best method for converting, but by the time you get done with cover-up method, you're like, by the time you get done finding the intercepts, you're just like one step away from finding the slope, so you may as well just keep going. All right, so I'm going to zoom out a little bit. I'm going to write what goes over here. It's a little bit less, and then I'll give you all a minute to write it down. Okay, I'm going to, y'all pause it, and if you need to copy, I'm going to keep going, okay? So, the cover-up method, the way the cover-up method works is we find the intercepts, and then we use them to find the slope. Now, I'm going to do some examples. I don't want you writing anything, because again, when you guys write stuff down, you focus more on copying everything than you do on actually like paying attention. So I don't want you writing it down. We'll pause it. You can write it down later, but I want you to pay attention to what I'm doing for now. Okay? So this is the equation we're going to be using. 2x plus 5y equals 20. Y'all better put your pencils down. Don't you be writing nothing. Okay? All right. So if I wanted to find the x and y intercepts. So what does the y-intercept start with?
0.
It always starts with 0, right? Because it's 0 something because it's on the y-axis. Where do you think the 0 is on the x-intercept? It's there. Okay? So y'all probably remember that we call this one the y-intercept, we call it b. Right? Because it's the b in mx plus b. We're going to call the x-intercept z for 0. Now, let me explain to you why that is. When we get into quadratic functions, everything is about the zeros. Because the quadratic functions, the zeros tell you what the answer is to a quadratic equation. So zeros are really important in quadratic equations, and zeros are the x-intercepts. So the only way I've been able to explain what a 0 is, okay, here's this. I am Mrs. Deal. Okay, I'm Maggie Deal. My husband's David. His dad, we have Richard and Jennifer and all kinds of Deals. Why am I called a Deal? Because that's my last name. Well, this guy's last name is 0. So he's a 0. Okay, so like maybe okay, and I'll just, spoiler, the x-intercept for this one is 10, 0. So which 0 is he? He's 10, but he's a 0 because his last name is 0. Okay? So when you look at it, so if they ask you for a 0, you better cross off anything that doesn't have a last name of 0. Okay? Because the zeros have a last name of 0. Y-intercepts have a first name of 0. Okay? So if I want to find the y-intercept, and I have this equation, all I know about it is that its ordered pair starts with 0. So that means the x in that ordered pair is going to be 0. So could I plug in 0 and then solve the equation? I can. Okay. 2 times 0 is 0. Well, that 0 just goes away, right? So it's just 5y equals 20. And then I get y equals 4. So the y-intercept is 4. Now here's the thing, though. Okay, I'm going to make it even easier for you. If I know that when I plug in a 0 into the x, that it's going to disappear, right? Because I know I plug in the 0, it zeroes out, and then couldn't I just cover up the 0 and jump straight to this? Because I know that when I put in a 0 for the x, this whole term is going to zero out. I can just jump right to 5y equals 20 and get y equals 4. I could just jump straight there. Likewise, if I know that for the 0, the x-intercept, I'm going to plug a 0 in for y and zero this term out, couldn't I just say 2x equals 20, x equals 10? Couldn't I do that? That's the cover-up method. Okay? That's the cover-up method. Now, I will tell you, you can use the cover-up method to write a slope-intercept form equation. But I don't usually use it for that. But I'm going to show you how. It's an option. I use it when they give me the situations you might use it on is where they give you a graph or they give you an equation and they say, okay, which of these graphs matches this equation, and it's in standard form. Well, I can just use the cover-up method to find the intercepts. Boom, there it is. Because I graph the y-intercept, I graph the x-intercept, and then I see which line has those two things. Or maybe they give me 4 standard form equations on one graph and say which one matches. I can do the same thing. I can just very quickly find the intercepts on those and match it up really easily. Okay, so that's the first method. I'm going to write this down, and then I'm going to pause it and let y'all copy it real quick. You can start copying it now if you want to. Yeah, the bottom is actually not the cover-up method. I don't know what I was thinking. Okay, once you get this copied, I'm going to show you the next step to writing your. Okay, the second step, so right now I know that to write a slope-intercept form equation, I need to know what m and b are. Well, I already know what b is. It's 4. And hey, look, I have 2 points, right? 4 minus 4 is 0. 0 plus 10 is 10. That simplifies to negative 2/5. There's my slope. I use those 2 points to find the slope. Now I have y equals negative 2/5 x plus 4. I'll be honest with you, though. I don't usually take this next step, but you can. Okay? You can take the next step if you want to. But I don't, this last part here where I find the slope and write the equation, I don't usually do that. But you see how fast it was to do. So if you're already finding the intercepts, you're just one step away from finding the whole equation. All right? So that's the first method, which is cover-up method. I think you guys are going to actually like the algebraic conversion all day. I mean, it's like opposite year here. All day people have liked algebraic conversion better. It's really, really easy. We're going to use the same equation. Y'all watch. Again, watch, and I'll let you write it down.
Is it easier than the cover-up method?
I think so. Okay. So remember, when I put something in slope-intercept form, it has y by itself. It has an isolated y. So I want to get the y term isolated. The y term is the one that has a y in it. So remember, terms are little chunks of an equation, and this is a little chunk that has y in it. I take the letter, number, and sign. A term includes the letter and the number and the sign. If there's no letter, it's the number and the sign. okay? All of that makes up the term. So I want to get this by itself. So I have to subtract 2x from both sides. This zeroes out and leaves me 5y over here. Can I combine these? Why not? Because chickamango. I mean, if I have 20 boxes of staples and 2 pens, then I've got 20 boxes of staples and 2 pens. I can't put those together. They don't go together, okay? So again, this is just like if I was solving an equation, okay? So I could write 20 minus 2x and it wouldn't be wrong, all right? But I'm going to put negative 2x plus 20 for a couple of reasons. First of all, slope-intercept form is mx plus b, not b plus mx. And again, it's not wrong if you do it. But the other thing is that I know that me, Maggie, I am going to write, when I start working fast, I am going to accidentally pick whatever I see first as slope because I'm going fast, and that's when I make careless mistakes. So I don't want to do that. Step 2 says divide if needed by the coefficient of y. So remember, I want y by itself, but I have this 5 with it. So I need to divide everything by that coefficient. So these cancel out, leaving me with a y over here. Negative 2 divided by 5 is negative 2/5 x. 20 divided by 5 is positive 4, which is the same thing I got over here. Okay? So take a second and write that down. All right. So now that we've converted from standard into slope-intercept, now we're going to go back the other way. We're going to convert from slope-intercept back into standard. All right. Now, converting from slope-intercept, there is no cover-up method, by the way. We're just going to do 2 examples, and they're both algebraic conversion. There's 3 steps. Only one of them, 2 of them are kind of like if you have to. Okay. So step 1, you got to do every time. You have to isolate b, which is my constant. So my b in mx plus b. Okay, step 2, we're going to multiply by the denominator. And step 3, maybe flip. And this second step is also a maybe. Okay, take a. All right, so I'm going to do 2 examples with you because I want to be able to show you all the possible steps you might have to take. Okay, so the first one is the exact equation we were using up here. Y equals negative 2/5 x plus 4. Okay, so we're going to convert this back into standard form. Okay, so the first step is to isolate my constant because remember, in standard form, the constant is by itself. So I want to get this constant. And remember, the sign's part of it. So if this is negative 2.5x minus 4, the minus would be part of that sign. Okay? So, and I want to move this negative 2/5, sorry, over the thing. Sorry, I'm having a little trouble making words. So I have to add 2/5 x to both sides. So this one zeroes out. Can I combine y and 2/5 x? Can I? No, they're not the same kind of thing. So I have 2/5 x plus y equals 4. All right. Now, if there was no fraction, I would be done. I would stop there. And I would look to see if a was positive. Okay. But I have a fraction, so I have to multiply by the denominator. And this is exactly like yesterday when we talked about converting. You need to stop. We talked about converting forms, so converting equations or solving equations, and we're scaling up the equation. Okay, so 5 times 2 is 10 divided by 5 is 2x. 5 times y is positive 5y. 5 times 4 is 20. Just like what we started with. Okay? Okay. No, you're done. No, if you're turning it into standard form, you're in standard form. You're done. We don't just keep doing a circle of converting and back and forth and back. No, you're done. Once you get it converted to where it's supposed to go, you stop. Okay? Now let me just show you another one just so you know what I mean by flip. Okay? So for this one, Again, I'm isolating the constant, and the sign, that negative, is part of the constant. Okay? So I have to subtract 1/4 x from both sides, and we zero that out. So I have negative 1/4 x plus y, equals negative 3. Okay? I have a denominator, so I multiply everything by that denominator. That gives me negative 1x plus 4y equals negative 12. Now, the second rule of Fight Club, is you don't talk about Fight Club, but the second rule of standard form is you can't have a negative a value. So if I want to flip this one, I got to flip everything. So if I flip one thing, I got to flip everything. So flipping this negative 1x makes it positive x. Flipping this positive 4y makes it negative 4y. Flipping that negative 12 makes it positive 12. And that's my converted form. And that's all three possible steps. And again, if you get to this point and there's no fraction, don't do the multiply by the denominator. You ain't got no denominator to multiply by. If you get to this point and a is not negative, then you don't need to worry about flipping. The only one you have to do is isolate your b. The other ones are if you need them. Okay?